Okay, so let's take a look at this physics worksheet that I gave you on momentum and the conservation of momentum. What we'll look at here in the first question is you have one freight car, mass A is 25,000 kilograms, and mass B is also 25,000 kilograms. Before, this one was moving 10 kilometers, VA, 10 kilometers per hour, which turns out to be 2.78 meters per second. If you were to convert it, VB is going 0. They stick together afterwards, so you only have one object after. You don't know its speed. You do know the mass of that object is 50,000 though, because it's both of them, and they are identical, of the same weight. So when you set this question up, you've got two objects before, MAVA plus MBVB, and afterwards you just have one object, MV prime. Your second object is not moving, so that is 0. So your formula is really MAVA divide by the total mass gives V prime. So you're taking 25,000 times the speed of 2.78 meters per second, dividing by 50,000 kilograms. This was kilograms. It's 1/2, so you cut that in half to get their final speed, and you get 1.39 meters per second is the speed. Okay, so for number 2, nice straightforward question. Two blocks traveling towards each other. One has a speed VA of 10 centimeters per second. VB has a speed of negative 60 centimeters per second because it is going towards each other. So one has to be plus, one has to be minus. After the collision, the second, that's VB, is traveling at a speed 20 meters per second in a direction opposite to its initial. VB was going to the left, it is now going to the right, so VB prime is positive 20 centimeters per second. The question wants to know, what is the velocity of the first block after the collision? We're looking for VA prime. Now, the only thing that makes this a little greasy is I did not tell you what any of the masses are, but I told you, so you've got MA and MB. But I told you that the first block is twice the second's mass. So MA is twice MB. And this I can use later on in this question to help me out. So I'm going to write my formula down, that MAVA plus MBVB is MAVA prime plus MBVB prime. I'm going to substitute some numbers in here. So MA times, without the units, 10 plus MB times negative 60 equals MA VA prime plus MB times 20. Okay, but now there's a whole bunch of MAs and MBs. Everywhere I see MA, I'm going to put 2 MB because they are indeed equal to each other. So this is 2 MB times 10. This is minus 60 MB. This is 2 MB VA prime. And this is 20 MB. Now, having done that, I have an MB everywhere, so the mass cancels out everywhere. So my formula now is 20 minus 60 equals 2 VA prime plus 20. 20 on both sides. So you have negative 60 equals 2 VA prime, negative 30. So it's going 30 centimeters per second, and negative meant left, according to my picture. Sound good? So let's look at third question. Lots of puns in here. This makes this an awesome question. The road in Captain Physics' neighborhood are slightly more crowded these days since he's taken up jogging. The crowding comes from the crew that helps him get through the physical fit that is overrunning the country. Miss Fizz marks off a new course each day, while Dork Boson mans the stopwatch. Lepton the Wonder Dog is there at the end, supporting a tray of cereal, fruit, and bacon on his nose, a balanced breakfast. And Captain Physics does have one quirk. He doesn't use shoelaces. As a result, his shoes always look like they're ready to come apart, and don't most joggers finish with their tongues hanging out after all. But alas, this is the day that Captain Physics gets tired of it all. There's a tire at the end of this. His course takes him through the local park, but a thick fog has decreased visibility. As a result, he runs into a swing made from an old tire suspended from a long rope. Captain Physics gets flattened as he and the tire move off at 8.2 meters per second. I give you Captain Physics' weight, not his mass, but I do give you the mass of the tire. And how fast was Captain Physics running initially? Okay, so almost all of this question means absolutely nothing, right? You don't need any of that information. What you do have is you have Captain Physics running, and you have tire suspended from a tree. Okay, so this is your object A, this is object B. VB is not moving before, VA is, but we don't know how fast. This is 10 kilograms. Afterwards, they stick together and move off as one mass and one speed. The speed is 8.2 meters per second. The mass we're about to work out. So we need the mass of Captain Physics. I told you that his weight, we need a bit more room. I told you that his weight, Fg, is 750 newtons. So you divide that by 9.81 meters per second squared to get his mass in kilograms. And that comes out to 76.5 kilograms. That is MA. So the total mass after is 86.5 because you add the 10 kilogram tire. And we're ready to solve this question. So it's just an MAVA plus MVVB equals MV prime question. Speed of tire is 0 before, so that's gone. So it's really just MAVA over M to get VB prime. So we take our mass of Captain Physics, 76.5 kilograms. Oh, sorry, we're not solving for V prime. Oops. Let's rearrange this properly. We're solving for VA, so we take the MA over and divide that way. So the total mass of 86.5 kilograms, 8.2 meters per second, divide by the mass of Captain Physics, 76.5, and that number comes out to 9.27 meters per second is the speed of Captain Physics before. Started solving that the wrong way, sorry. All right, last question. Even more puns, terrible as they are. The local harbor is full of activity at the annual water skiing championship. Most of the spectators are enjoying the luxury of a yacht or a houseboat, the names of which reflect their owners. For example, the bank's president is the wealthy Dolphin. This in sharp contrast to the popular houseboat owned by Underwood Figures' The Lone Shark. This seems to be a high level of interest in that boat. The commanding officer calls his vessel the CO, while his son, the chemist, calls his the CO2. Then there's Captain Physics. Unable to afford a real boat, he and Miss Fizz float to the viewing area on a raft that they've aptly named Archimedes Prince. While sitting and sunning, Captain Physics notices everyone yelling and waving their arms in his direction. At first, his ego is buoyed by all the attention, but his heart sinks when he realizes that they've stopped right in a skier's path. Captain Physics and Miss Fizz, this is the beginning of the question, Captain Physics and Miss Fizz quickly dive off opposite ends of the raft, each at a velocity of 3 meters per second. If the raft's mass is 150, Captain Physics and Miss Fizz are 75 and 55 respectively, what is the resulting velocity and direction of the raft? Okay, need a good picture. So we have raft floating in the water. We have Captain Physics leaping off of one side of this raft. And we have Miss Fizz leaping off the other side. And then you've got the raft itself. So this one we actually have 3 objects, A, B, and C. The total momentum before is 0 because it ain't moving. That means the momentum after is also 0. The momentum after is all 3 of those momenta added up. So this is PA prime, PB prime, and C prime. Have to have a sum of 0. So MA VA prime, MB VB prime, MC VC prime equals 0. We know most of these, we're trying to solve for the V of the raft. So we'll label the information on my picture a little better now that you can see the formula. MA is 75. VA is -3, because I'll choose this way as negative as the usual convention. MC for Miss Fizz is 55, and her speed is +3, going in that direction. The raft is 150, and we do not know its speed. So what you're going to solve then is take this term to the other side, that term to the other side, and subtract and divide by MB. My VB prime will therefore be minus MAVA prime minus MCVC prime all over MB. So you have minus MA is 75, VA prime is -3. Then you subtract MC, Miss Fizz, and her speed of +3, divide by mass of raft. So you get 225 here, minus 165 there, over 150. Which gives you 60 over 150. You know that's mental math. Gets you down to 4 out of 10, 2 out of 5, which is 0.4 meters per second. But you could have drawn your picture in any old direction. You could have drawn Miss Fizz going the other way. So even though you get a positive, and that positive indicates to the right in this picture, you really, because somebody could have drawn Miss Fizz going to the left, you would say for your answer that it is 0.4 meters per second in the same direction as Miss Fizz. That way, whichever way you called positive or negative, the raft is going the same way she went, because his momentum slightly exceeds hers. So the resultant goes backwards the other way. All right, so that is all 3 questions with terrible puns, all 4 questions, excuse me, 2 of which had terrible puns in them. You should be ready to go with an assignment.